In this film, we shall study scientific principles involved in the operation of common home electrical appliances. The modern home has electrical circuits supplying energy to many electrical appliances. The lead-in wires connect to a main switch. From the switch, wires lead to a meter which records the amount of electrical energy used, and then to a fuse box from which branch lines lead to all parts of the house. Each branch with 2 wires ends in a service outlet. An appliance such as this lamp with a plug completes the circuit. Home electrical appliances such as this electric range, electric roaster, and many others depend on the fact that electricity produces much heat as it passes through certain substances. These electric heating appliances are used in cooking foods, in the sick room, and in laundry work. Of these, the electric iron is the most widely used. The iron illustrates the principle of the common electrical heating appliance. This pressure plate holds the heating element firmly in place. Sheets of mica separate this heating element from the metal of the iron. Mica is an insulator and does not easily conduct electricity. The actual heating is produced in this resistance wire. In this iron, the resistance wire is wound around a sheet of mica. The passage of electrons through the resistance wire produces heat. This heat is transmitted to the base of the iron. The motion of the electrons is a representation of an alternating current. Overheating or dropping an electric iron may cause damage to the heating unit. If the damage is in the resistance wire or in the insulating material, the iron can be restored to usefulness by inserting a new heating unit. Many modern irons include a temperature controlling device called a thermostat. The principle of the thermostat mechanism is shown by this animated drawing. At the top is a strip consisting of 2 metals welded together. As the iron cools, the strip again straightens out and makes contact. Electrons flow through the circuit. As this iron heats, the lower metal of the strip expands more than the upper metal. This causes the strip to bend and again break the contact. No electrons can flow, and the iron cools. This alternate closing and opening of the circuit maintains a nearly constant temperature. This action of a bimetal strip is the principle of most household thermostats. The incandescent electric lamp uses a resistance wire to produce light. The intensity of the light produced by the heated filament depends upon the length, the size, and the material of which the wire is made. Modern floor lamps direct much of the light upward for more even illumination. The fluorescent bulb is more economical because more of the energy is converted into light. A glow bulb switch starts the action. When the lamp is turned on, some electrons flow across the gap in the glow bulb. The heat from this arc causes a bimetal strip to make contact, eliminating the arc. Many electrons now flow through the metallic circuit, heating the filaments in the fluorescent bulb. The bimetal strip cools, bends, and opens the upper circuit. At that instant, electrons given off by the heated filament start to flow through the lamp. Let us repeat. Lamp switch, glow, contact, heating of filaments, cooling of bimetal strip, breaking of starter circuit, lamp lights. The fluorescent bulb contains mercury vapor molecules shown as black dots. The moving electrons frequently collide with the mercury molecules, causing the molecules to give off invisible ultraviolet radiation. The inside of the glass tube is coated with a fluorescent substance. The short-wave ultraviolet radiation strikes this coating and is absorbed. The fluorescent material then emits a longer wave radiation, visible to the eye and called light. Electricity is also used to operate motors, as in the washing machine, in the dishwasher, in the electric mixer, and in many other appliances of everyday convenience. Of course, all of these motor appliances involve other physical principles besides electricity. The vacuum cleaner is one of the common home appliances driven by a motor. The fan which draws the dirt into the cleaner bag is connected directly to the motor. Let us start the motor and see the fan as it revolves. The revolving part of the motor is called the armature. This armature connects with the electric circuit by means of two graphite rods called brushes. If these brushes become worn down, replacement is easily made by unscrewing the cap over the spring which holds the brush in position. The worn brush is then removed from the spring and a new brush is inserted. The spring and brush are placed in position and the cap replaced. This is a common type of motor repair. The common type of electric refrigerator also depends upon the use of a motor. The electric motor drives a compressor pump. Pipelines connect the compressor with the condenser and with the evaporator. A refrigerant is used which normally is a gas, but which can be changed to a liquid by compression. The compressor pump, driven by the motor, draws the gas molecules from the evaporator above and forces them into the condenser, thus compressing the gas. In the condenser, heat is withdrawn from the gas by the cooling surfaces. Because of this cooling and the high pressure, the gas molecules condense to a liquid. A fan, also driven by the electric motor, is sometimes used to carry away this heat. Here we see the compressor pump, and here is the condenser with the fan in back of it. The liquid is forced into the evaporator through a needle valve. Here, under reduced pressure, the liquid evaporates and becomes a gas. In this process, heat is withdrawn from the freezing compartment. The pump again draws the gas from the evaporator and forces it into the condenser, where it again liquefies, and the cycle begins again. As a result of heat being withdrawn from the freezing compartment, convection currents are set up in the air within the refrigerator. Cold air is heavier than warm air, hence the cold air moves downward from the freezing compartment towards the bottom of the refrigerator. The air which has been warmed by heat taken up from the foods is forced upwards. This warmer air comes in contact with the freezing unit, is cooled, and the circulation continues. Electrical appliances should be properly maintained. This consists of such factors as regular inspection, repair, cleaning, and oiling. Electrical appliances should be carefully selected for sturdiness of construction and economy of operation. Wise selection and proper maintenance will assure long life of operating usefulness.